Here we are, Math 1, graphing practice. So these first pages are kind of just a reminder of some notes and what we're dealing with. So we're dealing with graphing, and we're dealing with linear equations, which follows that arithmetic growth, remember, plusing or minusing over and over and over and over and over. And our exponential equation, which is that geometric growth, which is multiplying and dividing over and over and over. Okay? So the first thing to note about linear, okay, typically we want to get the equation in slope-intercept form. That gives us our start number, right, which is A. We also call that our y-intercept, the place where it crosses the y-axis. Okay, and our slope, or growth as we call it, usually we call it growth, but in linear equations we like to call it slope, which is the number with x. Now it could be written y equals bx plus a. Okay. Sometimes you'll also hear y equals mx plus b. But I prefer this way because it matches up better with the format of our exponential. But it's the same as y equals mx plus b. Okay? So, and once we've got that start number and that slope or growth, it makes life a lot easier. Okay? Because it's easy to make a table, it's also easy to graph. Okay? So looking at our first equation here, y equals 3x minus 1. So 3 is the one with x, so that's our slope. So it would be 3. And we usually make it a fraction. So to make it a fraction, we'd have to put 1 under it. Okay, the top number is our growth in y, the bottom, x. X is the horizontal, y is the vertical. Okay, so as I look at this, I would start at negative 1. So our y-intercept is 0, negative 1. Because our y-intercept never has an x value, it's always 0. So I start my point right there at negative 1. Now, every time I'm moving x to the right 1, I'm going up 3. So I would move to the right 1, and I'd go up 3. Or you could think about it, every time I go up 3, I move to the right 1. And that's my next point. And that's the pattern. So from this next point, I go up 3 to the right 1. And then that is the pattern that I can just continue to follow. Okay? Because I know the pattern, I can also go backwards the same way, right? Since I went up 3 into the right 1, I would go down 3 into the left 1. And that's the same pattern. Oops. Ooh, can't really quite seem to get that one right where I want it, can I? Then down 3 to the left 1. Okay, now do I need to draw all these points? No, but it helps when you're trying to draw a straight line to have more points connected. Okay, now I can also use that equation to easily make a graph, or a table, right? My start number was negative 1. Remember, we always start at 0. Now, because of this 3, it means I'm adding 3 each time, right? The y goes down. Now, because there's no number under it, we always assume it's 1, so on the left, we're adding 1 each time. So every time my x goes up by 1, my y goes up by 3. Okay? There's that same slope that we see when we go up 3 to the right 1. Okay? And that's how we graph it. Now, what if we're given an equation like this? 3x plus 2y equals 10. Well, I could try to just make a table and plug in some numbers for x and figure out what my y's would be. That always works, okay? So I could pick numbers, and then I could say, well, what if x is 0? What happens? What number do we get? Okay, and go on that way. And that works perfectly fine, but I think there's an easier way to do it, because you'll end up doing this anyway. In order to get it in this format, we need y by itself. So if I get rid of this 3x, which I do the opposite, it's a positive 3x, so I subtract 3x, that becomes 0. Adding 0 does nothing, right? So we just get rid of it. That plus stays positive 2. Now, 10 and 3x can't be combined, right? Because remember, negative 3x really means negative x plus negative x plus negative x, or negative x minus negative, or x minus x. Okay, 10 doesn't stand for an x, so they can't be combined, but I can just rewrite them like that. Then I separate the 2 by division, so everything gets divided. That becomes 1. 1 times y is just y. 10 divided by 2 is 5. 3 divided by 2 is 1.5. But I can write it like that, but I would just prefer to leave it as a fraction, 3 over 2x, because our slope is typically a fraction. Now that y value, okay, connects the y values here. And that x value is the x values. Okay, I'm going to erase this right now so I have some space. So, we've got our starting point, right? Positive 5, so 0, 5. Now, here's where the fraction kicks in. Okay, because my y is moving up by, actually down, because it's minus 3, isn't it? That negative, think of it as the y. Minus 3, but is it every 1? No, because my bottom number is 2, so my y value is going down by 3 every time I add 2. So in other words, it would be something like, you start out with $5 on your lunch account, and every 2 days you spend $3. So, how much in the hole are you after 10 days? So this we could count by 2's, and this would go down by 3. Okay, and so on. And then we can graph that either way. I can look up 5 and say, okay, there's my y-intercept right there. Now I'm going down 3 to the right 2 because it's negative. So that negative makes me go down. So I go down 3 and to the right 2 for my next point. Down 3 to the right 2, down 3 to the right 2, and so on. Or I can do the opposite. The opposite of going down obviously is up. So I'd go up 3, but I have to go to the left 2. Okay? And that would be that line. Okay? And then whenever you have more than one line on the same graph, that point where they intersect, that's important. That's where it's a solution. Remember, all these points are solutions to our equation. Okay, if I plug them in, 2 and 2, 3 times 2 plus 2 times 2, it's going to equal 10. Okay, it's a solution. Now, you may be saying, well, what if I made it 1.5x? Here's the kind of cool thing about it. You're going to get the same thing because slope is the same. So, just with 1.5, it's saying, I start at 5. Now you're saying, because it's negative 1.5, I'd put a 1 under it if I made it a fraction. So this side would be going up by 1. As this side goes up by 1, my right side would go down by 1.5. So this would be 3.5, then 2, then 0.5, then negative 1. So see, by the fraction, we just went every 2, but we're getting the same thing. Okay? Graphically, it would work the same way. We'd start at 5, and then we'd go down 1.5 to the right 1, down 1.5 to the right 1. See, we end up with the same exact numbers eventually. Okay? But that's our linear growth. That's how we graph it. That's what we want to do with it. Okay? So let's graph some of these. We'll come back to the exponential. Let's just practice some of these. And you should try these on your own first and use my video to check. Okay? So we start at negative 4 because that's not with the x. So my point is negative 4. And if you have to, go like this. A equals negative 4. That's my y-intercept. That's 0, negative 4. My b, my slope, is negative 2/3. Make the negative go with the top. It's just easier that way. That's my y. That's my x. So I'm going down and to the right. Okay, so I go down 2 to the right 3. Or the flip side if I run out of space. Now, do I need to really do more dots than this? No, because if I know it's linear, I know it's going to be a straight line. I know it's going to follow that pattern. But if I really need to, I can go up 2 and to the left 3. Just do the opposite pattern. and then I draw my line. And that's all we got to do. Okay, that's all there is to it. So where did I start? We start at -3. Where are we going? 1/5, so that's up 1 to the right 5, because it's positive. Up 1 to the right 5. I'm running out of space, so I can go down 1 and to the left 5. Do the exact opposite. And then graph it. Okay. Okay, number 5. Same idea. Now, when it's just a negative x, remember that's like -1x. So if I made it a fraction, it would be like -1/1. So my y value, I'd go down 1. My x, I'd go to the right 1. And then where did we start? We started at +3. So +3. Then down 1 to the right 1. Down 1 to the right 1. And we'd follow that pattern. Or going backwards, which we don't have to. I could just sketch my graph right there. For this, that's all you really needed to do. But I could go back 1. Go up and to the left. Okay, number 6. Y equals 2x plus 5. So to make my slope a fraction, I put a 1 under it. So that means I go to the right 1 as I go up 2. And where do I start? I start at 5, so 0, 5. Now, notice that I'm running out of space on the graph. Could I try to go to the right 1 and up 2? Yeah, but if I run out of space going one way, just go the opposite, which would be down and to the left. Down 2 and to the left 1. Get enough points that I feel comfortable drawing my line. And because we're just dealing with equations, it's going to continue. If these were story problems, that would throw things off a little bit, and we'd have to adjust what we do. Now, 7 and 8 are those more difficult ones. Okay, with the x and the y together on the same side, this is actually called standard form. It is very useful in some situations in helping us figure things out. But if we don't know what to do to graph it this way, let's change it. To change it, and this virtually works the same every time we try to change it, and I'll show you that with this. First thing we have to do is get rid of the x's, right? So it's +3x. I'm going to subtract a 3x on this left side. On the right side, it's a +x, so I'm going to subtract an x. Okay? In both cases, we dealt with x's. Alright, got distracted there, so I forgot where I was at. Anyway, looks like we're solving these. Now notice we always, when we have the x and y on the same side, we're always going to either add or subtract that x to get rid of it. And we know that these can't be combined. We know that'll be 0, so we'll end up with 2y equals 6 minus 3x. Or in this case, -4y, the negative stays with it, equals 4 minus x. Okay? Same process. And then what's that last step? Dividing by that last number to get the y by itself. Okay? Then we simplify. So we get y equals 6 divided by 2 is 3. -3/2, leave the slope as a fraction, or dividing by 4, we get y equals 4 divided by -4 is -1. Negative x divided by -4 is positive 1/4x. Okay? And now we can graph. So we start at 3. We're going down 3 because it's negative, so down 3 to the right 2. Make those dots a little better. Down 3 to the right 2. Down 3 to the right 2. And then draw your line. Or in this case, we start at -1 and then 1/4, so we're going up 1 to the right 4. Or down 1 and to the left 4 to make our line. Alright? Okay, now we've got those exponentials, so let's take a look at those ones. So with exponential, kind of the same idea. We've got a times b to the x. Okay, that a, once again, is our start number, our y-intercept. The b now, we don't call it slope, we call it constant ratio, or just the number we're multiplying by, our growth. Okay, so once again, making a table is pretty easy. Now, y equals 3x, there's no number out here, out front, right? So what's the only number we could put there? Would be a 1. So we start at 1. Our a was 1, and our b is 3. So every time we go up by 1, we're timesing by 3. Okay, and so on. So it's probably easiest on exponentials to make a table real quick and then just to graph your points 0, 1, 1, 3, 2, 9. Okay, and then 327 would be clear up here. So, and you've got to remember with exponentials we have some basic shapes to our graphs. Okay. So we have what we call that asymptote. Unless we have a plus or a minus going on here, your asymptote's always 0. So there's this invisible line on the x-axis that we're never going to cross. So most of the time with exponentials we start to the left, and then we hit that y-intercept, and then we shoot up pretty quick. So when we graph it, we always need to realize we're actually going out for a ways, and then we're going to shoot up like that. Okay. Now we also have ones, these ones are called the growth. If we have a number bigger than 1 that's our multiplier, we're going to hit that. If we have a fractional or a decimal one, then it's going to be going down like this and be kind of that flip side of it. Okay? So looking at our second equation, okay, 4 times 2 to the x, so we start at 4. There's our y-intercept. Okay, 0, 4. And typically our x's, we're always going to count by 1s. Okay, if not, it really messes things up. So we start at 4, and then we're times them by 2 each time. So we'd have 8. So 1, 8. Then we'd have 2, 16. Okay, 16 right there. Then 32. Then 64, and so on. So once again, it's going to start out low here and then shoot up pretty quick. Okay, and there's our second one. Alright, so let's take a look now at those exponential graphs. Okay, so it's y equals a times b to the x. So we start at a, so I start y-intercept at 2. Then we're going to be times them by 3. Okay, so if I make a quick graph, timesing by 3 would give us 6, so 1, 6, then 2, 18, and then 3, and that one would go a lot bigger. So sometimes if you really want to get the best shape you can, it might be better to draw a few more points, and maybe to even go a bit the opposite way, like -1, -2. That'll help you understand how this graph is actually curving to hit that asymptote. So we had 6 and then 18. So going backwards, we do the opposite. What times 3 is going to give us 2? Or in other words, 2 divided by 3. Okay, so 2/3, which is about 0.6. So as we go to -1, about 0.6 would be like right there. Then if we divide by 3 again, it would be 2 over 9, which that's really small as a decimal. So you can see we're getting smaller, and so we'd ride that x-axis till we, and that was horrible on my last point, till we shoot up here. You should never make your graph go down like that. That's a no-no. Okay. Alright, now, oh no, we've got a fraction. No big deal. Okay, that's our starting number, so we start at 0.5. Okay, if you have to, change it into a decimal. So at 0, we start at 0.5. Then I'm timesing by 5 each time. Okay, well 0.5 times 5 is 2.5. Okay, so we'd go up to about 2.5. Then timesing that by 5, we'd get 5, 2, 12.5. Okay, so about 12.5, and so on. Okay, so we'd start here really low at the x-axis, and we'd jump up and draw our graph. Now, the ones that are difficult are these guys. Now, notice our fraction is the multiplier. So in other words, okay, we have our starting point, 0, 3. So as it keeps going, and actually let me, with this in mind, let's go like this to show you guys something. Okay, so we started at 3, and we're timesing by a half. Okay, timesing by a half is the same as dividing by 2. So we'd have 3 divided by 2, which is 1.5, right? Then divide that by 2 or times it by 1/2, and we have 0.75. Times that by a half, and we have 0.375, I think. Let me grab a calculator to double check. Yeah. Okay, now that's just getting smaller. So 0, 3 would be here. 1 and 1.5 would be here. 2 and 0.75. Okay, that's a tough graph to see. Once again, we're not going to go below here, even though it looks like we might. So it's good to go backwards, because what's the opposite when we go backwards? Instead of dividing by 2, we're timesing by 2. So that would be 6. Negative 1, 6. 2 would be 12. So negative 2 up to 12. And then up to 24. Okay, so you can see now a better shape of that graph, and it's just going to ride that x-axis. So that's what we call decay. When you have a fraction in between 0 and 1 here, they're going to look that way, as opposed to here, where you have a number bigger than 1, we're multiplying by, it goes up. Okay, so this one, now this one's tricky because you're dealing with these fractions. And with exponentials, I'd say usually you want to do around 5 numbers. So we start at 1/3, or 0.3. Okay, we're timesing by 1/4. So using a calculator, that would give us 1/12, which would be about 0.08. Okay, if we keep going that direction, okay, we're just going to keep making a smaller and smaller number. That's like 0.02. So we're starting already at 1/3, and we're just getting really, really small. Okay, so this side of the graph is basically already at the x-axis. So let's go backwards now and times by 4. Okay, so 1/3 times 4 would give us 4/3, or about 1.3. Okay. So see, we're going up now a little better, about 1.3. Do that again. Okay, now we're getting about 5.3. Okay, and so we can see that we are moving up, so it's going to go something like that. Okay, and we get that same basic shape. Alright, now what happens when we have multiple equations to solve? Well, we just do them together. So do one at a time. So we start out at 1, because this is linear again. And then my growth is 2, so I think of it as 2 over 1. So up 2 to the right 1. And when I've got more than 1, I try to write as many dots as I can, because it's easier that way. So going the opposite, we go down 2 to the left 1. And then I draw my graph. Then if you have a different color, it's a good idea to use that. But this one I'm going to have to solve, aren't I? So using that same process, we subtract 2x. So I end up with 4y equals 8 minus 2x, divide by 4. And I get y equals 2 minus 1/2 x, because 2 divided by 4 reduces to 1/2. So I start at 2 here, and I go down 1 to the right 2. Or up 1 to the left 2. Okay, and there's my graph right there. Now, can I tell where they intersect? Not really, but it's a good idea to just point that that's an intersection point. Okay, now 14, same idea. Start at negative 4. My slope is positive 3 over 2, so I go up 3 to the right 2. Remember, the number on top always tells us how far up or down we go. Where I go backwards, down 3 to the left 2. There's my first one. Okay, then I've got a plus 2 to start off here, and then a negative 3, so I think of it like negative 3 over 1, so down 3 to the right 1. 3 into the left one. Then we draw that equation. Okay, look at this and say it looks like it intersects right there. Do I know exactly where that is? No. But if I really wanted to, I would just graph this on some technology to help do the hard work for me. Okay, now we've got a linear equation and an exponential. Okay, so now we're making it a little more difficult, but still start out graphing them. So exponential, we start at 2, so 0, 2. And then we're times them by 4. So 0, 2, times them by 4, give us 8. So 1, 8, times by 4 would be 32. So it's clear up there, right? If I were to go backwards and make a negative, okay, we divide by 4. So 2 divided by 4 would be 1/2. Then 1/8. So that's going down pretty low. So then I draw my graph like this and take it up. Okay. Then I graph this one. So starts out at 7. So right there. Slope is -2, so -2 over 1, so down 2 to the right 1. Just make sure that you're paying attention to how this is counting by 2's. Okay, there's my graph. So it looks like it intersects once again, right there. And there's my 2 graphs together. Okay, then we do it for 16. Okay, these are the 5 numbers I like to do with exponentials. So we start at 4, so 0, 4. Then we're timesing by 1/2. So timesing by 1/2 is like dividing by 2, so that would be 2. So 1, 2. Then 2 divided by 2 would be 1. So 2 goes up to 1. Notice we're counting by 2's on the y. And then it would be 1/2. So 3 goes down and then lower to that x-axis. But if we're going backwards, we're timesing by 2, because that's the opposite of timesing by 1/2. So at -1, we'd go up to 8. At -2, we'd go up to 16. And then 32. So that gives us a pretty good shape of where our graph is going. So we do it like that. Then we do our other exponential. Apparently this is 2 exponentials. So 3 times 2 to the x. Okay, so we start at 3. So 0, 3. Okay, then we're timesing by 2. So that would be 6, then 12. So 1, 6, 2, 12. Then 3 would be 24, right? Going backwards, we'd divide and we'd have 3/2, so that would be -1. Then 1.5, about right there. And then that would be 3/4, which is like 0.75. So we'd look like this for our second one. Okay, so they intersect right about there, which would be the solution to both of them. Alright guys, there we go with all that lovely graphing. Make sure you copy down those notes on that worksheet as well, so that you can have that to help you out. And there we go.